All right, the distributive property is an extremely important property. I guess they're all important, but this one, what I mean by that is that you're going to find yourself using the distributive property a lot in just about any higher math class, as well as other science oriented classes as well. Um, so, what is the distributive property? So one of the uses of the distributive property is to remove grouping symbols, such as parentheses, brackets, and braces. And you use the distributive property to simplify expressions. So one example, let's say you've got 3, let me put it off to the side so it's easy to read. So 3 times x plus 4, you distribute this 3 to each term inside the parentheses. And this is going to be the same as 3x plus 12. So 3 times x is 3x, and 3 times 4 is 12. And this is addition, so you just carry that addition over. So this is relatively, simple to look at, and you can have ones that are as complicated as this second example. So in this example, we have different grouping symbols. We've got braces, brackets, and parentheses. And so what you want to do is you want to start from the inside out. So the innermost, the innermost grouping symbols is going to be this parentheses. Now, we cannot add these two terms together because they're not like terms. X and -5 are not like terms. So this is where we use the distributive property to multiply 4 times x to give us 4x, and 4 times -5 to give us -20. Now notice when we did that, these parentheses that I've written in red here, they're gone. All right. So by applying the distributive property, we can remove grouping symbols. That's what I was referring to earlier. Um, so now with the parentheses gone, we can now look at the next inner layer, which are these brackets here. And notice that we've got like terms right here, x and 4x, and we can combine like terms. So this next line down here is with these like terms added. So x plus 4x gives us 5x. We still have this -20, and the brackets are still there. And then we've got -3 on the outside, and then 5 braces with a 2 out here outside the braces. Okay, so we can't subtract 5x and 20 because they're not like terms. But we can distribute the -3 to 5x, which will give us -15x. And then we can distribute this -3 to -20, and that gives us a +60. All right. And notice that once we applied this distributive property, these brackets are gone. Okay, the brackets are now gone from the next step. So what we can do is we can combine like terms. So 5 and 60 are like terms. So that's why we get 65, and we haven't done anything with the -15x, that's still here. And so we've done as much as we can inside these two braces. And inside these two braces, we've got 60, 65 and -15x. Well, we can't subtract those because they're not like terms, but we can use the distributive property and multiply by 2 by both terms inside that brace. Notice here that we got juxtaposition going on. So that's what's telling us that we've got multiplication here. And so 2 times 65 is 130, and 2 times -15 is -30. And so we're left with 130 minus 30x. We can't simplify that anymore. So we started with all of this, and we're able to simplify it down to this by using repeated iterations of the distributive property. So let's take a look at some examples, and you can do some of the think pair shares. So, let's simplify this expression using the distributive property. So notice inside the parentheses, we've got 3/8 x plus 1/4. We can't add those together because they're not like terms, but we can distribute the 8 to each term inside the grouping symbol. So I'm going to do this a little bit longhand. So 8 times 3/8 x, we're going to have 8 times 3/8 x, like that. And then plus, let me put that in parentheses, plus 8 times 1/4. All right. And so now with that distributive property done, these parentheses are gone. I left these in here just to kind of show what it is I just did and what I'm going to do next. So I'm going to write 8 as 8/1. And the reason why I'm going to do that is because that shows me that here I've got 8 in the numerator, and I can cancel that out with 8 in the denominator, leaving me with just 3x. And here I can write 8 also as 8/1, and I can think of as 8 as 2 times 4. And this 4 and this 4 will cancel, leaving me with just 2/1, or just 2. So this is the answer for the simplification of this expression. It simplifies down to that. The answer you should get for this think pair share will be 4n plus 9. So try that out and let me know if you need any help. Let's look at this next one. So this one is progressively a little more difficult because we have to apply the distributive property twice. So again, we've got these grouping symbols, and we can't add or subtract what's inside the grouping symbols because we don't have like terms. So we're going to distribute, and we're going to distribute. So here on the left, we're going to have 4x minus 32. All right, now what do we do here? Because I don't see a number. So what you want to do is you want to think of this as -1 times x plus 3. And so you're going to distribute this -1. So we're going to have -x minus 3. -1 times x is -x, and -1 times +3 is -3. So now we can combine like terms. And 4x minus x is 3x, and -32 minus 3 is -35. All right, the answer for this next think pair share should be 9x minus 13. So give that a try using this example as a model, and let me know if you have any questions.